That face that is usually covered by her phone has finally made an appearance. That face is laughing. That face is expressive.
All right, ladies and gentlemen, phones away. You're quiet. The video is starting.
Sam, what's wrong?
These quadratic equations are really burning my waffles.
It'll be okay.
Well, how do I do these things?
Maybe this will help.
What's the deal? What up, son? Hey, we're gonna show this class how to do the quad song. All you gotta do is flex on these students.
Stop in school when we like to do the dance. Flex to the left, get some pencils in your hands. We do it for our school and we do it for the grades. But to solve these quads, well, you gotta do the dance. Everybody do the quad song, quad song, quad song, quad song, quad song, quad song, quad song. Everybody listen, pay attention class. We're about to solve quads so that y'all can pass. We'll teach you 3 methods. X is what we're after. Start off first, watch.
Teach me how to factor.
I'm trying to tell them, y'all got to try this. If factor won't work for you, we'll go down our list. Just break it down into 2 quantities. They're linear factors, we solve them with ease. The zero product property comes into effect. Each piece should equal 0, and then you solve for x. Ha! There's a shortcut, if speed is what you want. The opposite of the back, divided by the front, and affects any part of a greatest common factor. Answer to the piece is 0, believe me, I'm a doctor. Mixing math with music, we help the students learn. Keep your minds open, this class is out done. School when you like to do the dance. Flex to the left, get some pencils in your hands. We do it for our school, we do it for the grades. But to solve these quads, well, you gotta do the dance. Everybody do the quad song, quad song, quad song, quad song, quad song, quad song, quad song.
I'm Mr. Winner, yeah, I teach it. The factor in it, how I preach it. We bend it and send it, but the times of factors just don't mend it. But don't you worry, we got another way to solve it. Complete the square, baby, that's the way that I dissolve it. Hang with me in my class and your grades will not diminish. Here's a lesson by my boy, he will get you to the finish.
Quadratic, you can get your terms on high to low. Divide everything by 8, you know that is how I roll. Move C to the other side, cut B in half, square it, add this to both sides. Try to me your perfect square, you just have to recognize this will simplify when you go around the lines. Ha! Yeah, stand tall, we call this the quad solve. All I do is solve, I get it and I can solve them all.
My boys all finished up, he be prime time. That's how we teach him well, mixing it with hero rhymes.
School when we like to do the dance. Flex to the left, get some pencils in your hands. We do it for our school and we do it for the grades. But to solve these quads, well, you gotta do the dance. Everybody do the quad song, 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 quad song.
Oh yeah, we solving until we falling. If you get to a problem, we can help if you be stalling. The quadratic formula, it is here to make your day. Whole class you do the dance, cause this is the 3rd way. Better take out your calc, cause some of these be insane. You gotta plug and chug, and soon you'll make it rain. First you find ABC and write it down on them. Now plug them in, put parentheses around on them. Fix up that discriminant sitting in the back on them. It'll be imaginary or so real on them. Class, go with bananas, I get it figured out on them. Plus or minus this to the opposite of B on them. Divide the top all by 2A on them. Time to start the class, about to give this test to them. Yeah, dub south, we gonna show them how to do it. Do the quad song, it ain't really nothing to it.
School where we like to do the dance. Flex to the left, get some pencils in your hands. We do it for our school and we do it for the grades. But to solve these quads, well, you gotta do the dance. Everybody do the quad song, 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 quad song. Who's ready for a farm
All
fresh
right,
breakfast?
so we are, if you didn't figure it out, solving quadratic formulas using the quadratic formula. So we're going to pick up with the next part of our notes, which is quadratic formula. So the quadratic formula is a way to solve any quadratic equation. We are going to use, as part of the quadratic formula, the discriminant. As we did yesterday, the discriminant tells me key pieces of information about the number and type of roots. And then what we do is use that to help us find the actual roots. Okay. So the quadratic formula itself is negative b plus or minus the square root of b squared minus 4ac all over 2a. And I had you guys listen to that song yesterday to try to hear the quadratic formula as Pop Goes the Weasel. The very first thing we have to do is set the equation equal to 0. After the equation is set equal to 0, then what we do from there is identify the a, the b, and the c, find the value of the discriminant, and then substitute everything into the quadratic formula and simplify. So why do we use the quadratic formula? The quadratic formula allows us to solve any quadratic equations, factorable or non-factorable. And again, that key important piece is the discriminant, b squared minus 4ac. And it's important to note that the discriminant does not include the radical. So from yesterday, just a review, the discriminant tells me several things. It tells me the number and type of solutions. Remember that another word for solutions is roots. The discriminant can be positive, negative, or 0, and it is under a radical that determines the solutions. So if it's positive, you have 2 real, negative, 2 imaginary, and 0, you have 1 real. And then we're going to add in a little bit of what we talked about again yesterday with, is it factorable? How do you know if it's factorable? And what is that called? Okay, so yesterday on your one worksheet, it asked you a little bit about rational versus irrational. So the idea is that you have rationals if they are perfect squares. Real rational solutions meant that that equation was factorable. If they're positive but non-perfect squares, then that's 2 real solutions. And those real solutions are irrational. A 0 is considered rational, and the negatives can also be irrational or rational with your eyes, depending on if you can simplify your square root. Steven, we're not eating or drinking in class right now, honey. Put the water away and fix your mask. Okay? So again, I know yesterday the handout said something about rational and irrational. And I know we briefly mentioned it, but it wasn't kind of as laid out as nicely as it is here. So I wanted to make sure I went over that so you did understand the difference between irrational and rational. Okay, so in that first example, we have find the value of the discriminant and describe the nature of the roots. Then solve the equation using the quadratic formula. So step number 1 is set our equation equal to 0. So what we're going to do is subtract 11 to the other side. So we have 2x squared plus 7x minus 11. Then you need to identify your A, B, and C. And then we're going to find the value of our discriminant. So the discriminant is b squared, which is 7 squared, minus 4 times a times c. So 7 squared is 49. 4 times 2 is 8. 8 times 11 is 88. And a negative times a negative gives a positive. So 2 negatives make a positive, 3 negatives keep a negative, and 1 negative keeps a negative. So 49 plus 88 is 137. So since the value of the discriminant is positive and a non-perfect, we have 2, and in this case, if you want to add it in, irrational roots. Because 137 is not a perfect square, which means that my roots are going to be non-integers. Oops. There we go. And then the last thing we want to do is solve the quadratic formula. So that's negative b. So in this case, our b value was 7. So that's negative 7 plus or minus the square root of 137 all over 2 times a, which was 2. So we get negative 7 plus or minus square root 137 all over 4. Since 137 is a non-perfect square and 137 isn't going to divide by any of my perfect squares because it doesn't divide by 9, 16, 25, etc. Because the numbers used to multiply it were also not going to get us there. So at that point, then, we are going to leave our answer exactly as it is. Now, if 137 divided by a perfect square, then we would simplify and potentially clean it up. If it was a negative, then we would have to take out an I. So in the case of this problem, we are done. So for example 2, you want to do the same thing. Step number 1, set it equal to 0. Identify my A, my B, and my C. And if you don't want to write down your A, B, and C's every time after this example, you don't have to. I'm just doing it to reiterate the importance of A, B, and C in the quadratic formula. And then what we're going to do is plug those values in to find the discriminant. So b is 2 squared minus 4. A was 1, and B and C is negative 63. So you have times 1 times negative 63. So again, 4 squared minus, 4, because 2 squared is 4, minus A is going to give you 4 times 63, which becomes positive. Add 4 to that, and we get 256. 256 is a positive, and it's also a perfect square, which means I'm going to get 2 real rational solutions, which also meant that this equation was factorable. So b is 2, so you have x equals negative 2 plus or minus the square root of 256 all over 2 times a, which was 1. So that gives negative 2 plus or minus the square root of 256, which is 16, all over 2. So now you split your problem, and you do negative 2 plus 16 over 2, and negative 2 minus 16 over 2, so that I can get 14 divided by 2, which is 7, and negative 18 divided by 2, which is negative 9, and that is my roots. So that's like saying x equals 7, x equals negative 9, and those are my roots. So we could actually see that that problem would have factored as x minus 7, x plus 9. So the quadratic formula allows us to solve factorable quadratics as well as non-factorable quadratics. Okay, so we have x squared minus 5x equals 24. So first things first, get it set equal to 0. Find your discriminant. Since my discriminant is a positive perfect square, I have 2 real rational roots. When I plug into the quadratic formula, it's x equals, so it's x equals negative b, which is 5, plus or minus the square root of the discriminant value, which is 121, all over 2 times a. So I get 5 plus or minus 11 all over 2, which is x equals 5 plus 11 over 2, and x equals 5 minus 11 over 2. So you get x equals 8, and x equals negative 6 divided by 2, which is negative 3. So once again, that tells me, since I got real rational roots, that this was also factorable. So when we take our Chapter 5 test, that's a decision you can make. There will be ones where I say you have to factor, but then there will be a group of quadratics, and it will be your choice if you want to do quadratic formula, completing the square, or factor. So we have x squared plus 6x equals negative 13. So we're going to add over that 13. Get my equation set equal to 0. Find the value of my discriminant. So what you should notice this time is we have 36 minus 52, which is negative 16. So the minute I get a negative discriminant, that tells me I have two imaginary solutions. And these are actually going to be rational imaginaries because 16 is a perfect square. So when I plug into quadratic formula, it's x equals negative b plus or minus the square root of my discriminant, which is negative 16, all over 2 times a. So I get negative 6 plus or minus a negative square root gets an I, and the square root of 16 is 4. So you get negative 6 plus or minus 4i all over 2, which is really negative 6 divided by 2, which is negative 3, plus or minus 4 divided by 2, which is 2. So this simplifies to negative 3 plus or minus 2i. You can only simplify if that denominator divides into both. So really what you're doing is taking that 2 and rewriting it over both terms. And does anybody know, so the formula for quadratic formula is x equals negative b plus or minus the square root and then technically this is all over 2a. If I broke the quadratic formula into those two pieces and I kind of put the negative b over 2a plus or minus the discriminant over 2a, what is negative b divided by 2a? What did this represent previously in our class? What did negative b divided by 2a represent? Oh, Jacob? It is exactly that. It is the axis of symmetry. So that represented the AOS. So think about what we're saying. We're saying in this problem that the axis of symmetry is at negative 3 and our roots are plus 2i to the left, or to the right, and minus 2i to the left. Shouldn't it make sense that the two roots are evenly spaced to the left and the right of the axis of symmetry, since the axis of symmetry cuts our graph in half? So technically when you're doing the quadratic formula, you're actually kind of finding the AOS as well, and it is built into that formula. So I think it's kind of nice to see that connection between graphing and solving by graphing, where we found our roots on the graph, as well as looking at the quadratic formula, which directly involves our AOS. So your homework is that next worksheet in the packet. There is lined paper out on my countertop. It is impossible to do all of those problems on that lined sheet of paper. I mean, not on a lined sheet of paper. The worksheet spacing is very, very minimal. So I want to see kind of exactly what we were doing in our notes. I want to see from you our discriminant, and then at least plugging into the quadratic formula and your simplified answers. So looking for those 3 boxed in parts to the work. We will play a Jeopardy review on Monday, and then on Tuesday we're going to do a quiz on simplifying imaginary and complex numbers with radicals, completing the square, and quadratic formula. Wednesday, we're going to do a graphing activity because on Thursday, we go back to graphing quadratics, but now we're going to graph quadratic inequalities. So it's kind of like a preview of where we're going to be a week from now.